Hello explorers and welcome to another video, and today it's day 18 of the Advent of Code. And this day we are collecting keys to the puzzles. And we need to collect all the keys because one of them will be to disable a tractor beam. And these puzzles are in a maze, like this one, where we need to go from this start position to A and back to this door here, large A, and then to B, and then we have collected all those. And we need to figure out how many steps to actually take. So in this case, we move 2 steps over, and then we move 1, 2, 3, 4, 5, 6 steps back. So the total number will be 8 steps for this maze. And then the mazes gets a little larger, and here we have an example where it's actually faster to go and fetch the second key here, C, before going back, because that will be a shorter distance. This is what we need to figure out, how we could move the shortest distance and get the fewest steps in. So that's a challenge. And the puzzle input for this one, you see, is large, with a lot of keys and a lot of doors, I guess. So this will be challenging as well to figure out which is the shortest path, and we start in the middle here. So yeah, I'll get on to code something and see what I figure out. I'll be back. And I'm back, and it's actually the day after, and this actually required me sitting down, trying to do something, realizing that it went really slowly, and some of the examples they gave were also really slow. So I took a break. It was late in the evening, went in, took a shower, as usual. In the shower, I realized how I could make it faster, went out, did some programming. It still took a long time to run, but I actually got a result for the puzzle. So let's try that on the site and see if it is the correct one. So it's 4,733. Let's see. Not the right answer. It's too high. Okay. So I need to see what's going wrong here. Interesting. I thought the algorithm was quite good at finding correct solutions, but maybe I did something wrong here. Thought something wrong. So the way it actually is looking at this is, let's see here, it's 81, yeah. So let's go through the code at least. So first off, we have the day 18 here. It's 81 times 81, so that's the ratio of the drawing. We create a new drawing, we read it in using this little function here where we look for the @ sign and set a 1 there. All the dots are zeros and the walls are -1. And all the characters we just put into the maze as they are spelled out as short. We print the map so we know that we have the right drawing here. Let's see if it looks correct. Yeah, it looks pretty much as it did in the example there. Then I create a collection here of paths, and that's a hash set. Doesn't really need to be that anymore, but I used the hash set because I wanted unique values. And then I created a list of done paths. So these are paths that can't be any shorter. And then I go through here and put one of the paths into the paths. And this is the full drawing. It hasn't any length. And we put in an empty key array and an empty position. We don't have any position at the moment. And then we go through it until changes are false. So while changes, and we set changes to false directly, so we know that we haven't done any changes. Then I will iterate through the paths. I create another hash map of new paths where I have a string and a key path. And key path is the little class that I use to keep all the data about this path. And this was a new thing that I added yesterday after the shower, because I realized that I could actually uniquely find relevant paths in my tree or in my collection. Then I go here and I take the next key path and I will get a collection of possible paths. And if that list of possible paths is larger than 0, I will go through each of them and take the current position. So I have a way to know where I am, a relevant position, and then I will see if that is contained in my new paths. If not, and if it is, I will see if the path I want to put into a new path has a shorter length than the current one. And if so, I will put that key in. Otherwise, I will just put the key into the array if it is not therein, and then I will set changes to true. And if the new path list is 0, I will add the current path that I'm looking at into my done paths, because now it's done. I don't need to look at that path anymore, and it should be a part of the paths that I will look at to see if I can find a path with a specific length. And then I will set the values of this hash map into paths, so I will go through those that are not done yet again. And I will type out how large that is. So if we look at the output here, we see that we start by 5 and it grows, and then it will shrink again back to 0 paths. And then I will go through and look for the minimal path, so the smallest path possible through the maze, and print that out, and it was 4733. So that was the path that I thought was the right path, but the example here says that this is too high, so I could actually find a shorter path somehow. When I've done that, and we can look at the key path as well. So let's go into that class. It has a lot of different functions here. We can start off by saying that it has the values of the size of the drawing and also the length of the current path. We have an initial drawing, so this is where this specific key path is starting out. And then we have the keys, and these are the keys that we have found before we actually go into this path, and the current position. So this is the actual letter we are standing at the moment. Either it's a door or it's a key. That's the current position. And then we will set those values from the constructor up here. And then I have a few different functions here. Hash code and equals are not important anymore, but those were looking at the different things in the current setup. But sadly, I couldn't use a hash set. It didn't really work with this set of data. And I also have a function to get length. Those are small. Current position, this was what I figured out in the shower, is the current letter we are standing at and the keys in the natural order. So if I have all the keys, for instance, A, B, C, D, and I'm standing at the door D, then that's my current position. And if that is the shortest path to that position, then I have found a way to find all these keys and come to this position, and this is the shortest way I can do that in. So that's why I'm saving this one, because it's a good way to see that I actually got here. And then we will check if we have drawn something. So this is check if we should draw something, and if the position that we are at is 0, so there aren't anything here, and we are close to any other marked spots, because we will mark spots as drawn, and this is the fill algorithm that I'm used before. Then I will say that I can draw here, and close to marker is just that any directions in the around this is a 1, and that's if we are close to the marker. So those are those functions. possible paths. I start off by going through creating an array of possible hash map of possible paths. I will create a new drawing. So I will copy a new drawing. I will remove the current position in the drawing. So I will reset all the ones. And that's because I want to reuse this initial drawing to set my new position at the new door or key that I find. Then I will have a path length here. I look if I still are filling. I will add to this path, and I will set still fill to false. I'll copy a new drawing here and go through it and see if I can fill somewhere here. So if I find somewhere where I can put some values in, and if if the position of the drawing is -0, so if it's a wall, I know I can't do anything there anyway, so I just skip that. Otherwise, I will see if I have a specific character here, and if this character uppercased is a door, so if it's an uppercase letter, it's a door. And if the drawing position is above 5, and so we know that it's not 0, it's not a 1, and so on, and the possible paths are not contained in this array, so we haven't seen this door or key before, and we are close to another marker, so we will draw here. We can draw here, and if it's either not a door or if we have that key, then we will create a new drawing. We will set the current position to 1, so we say that this is where we want to start off next time. We will create a new keys array. We will add all the current keys of this from this key path. We will add, if it's not a door, we will add another key, and we will add it as uppercase, so we can actually see if we have that key, so we don't have to lowercase all of them just to see if we have that key. And then we will create a new path and put that into possible paths, and we will reuse this S value here. So this is either a key or a door value as one character. That is our key of this map, so we know that we have seen this path before. And we will add the new drawing, the size, the new keys, the length plus the path length. So this is the length so far plus what we have seen as well. And then also add the current position. And then we will check if we should draw this like this. So this is if it's not a door up here. So I believe we could actually have an else here. So that this will probably make it go faster. And if we should draw, we put the 1 there, and we say that we are still filling. Yeah, and then we will copy the new drawing to drawing and continue. And when we have found all the possible paths, we will return those, and we will start over again. So this is the position we are at the moment. So I wonder what I can do to make this shorter? Because I believe we have tried all of the different possibilities here. Maybe there are doors that we are not required to open. Maybe that could be the case. So let's see here. We are looking for keys. So up here we can actually look at all of these positions and see if any of them are lowercase. Then we have a key, right? Boolean has keys left. False. And if any of them are lowercase, we have keys left. Let's see. So if has keys left, it's not true, and this is larger than 5, we can do that. So yeah, like that. And if not has keys left, return possible paths. Values. So that's something I can try. So we don't look for paths that can't actually find more keys. Because if there aren't any more keys to find, we don't need to go and open the last doors or anything like that. So this could be a solution to this. Yeah, I'll try this out and I'll get back to you when it has run. And we're back again, and we actually got a lower result now. So looking that we haven't just went around and looked for more doors to open, we only look at the actual keys that we need, actually got us a smaller result. So 3270, let's look at that and see if that's the correct result. 3270. And you get a gold star, I get a gold star, everybody gets a gold star. We solved that one. So I will read up on what we need to do next, and I'll be right back when I know what I need to do. Okay, so now I have read up on that, and it's actually that we need to do this in multiple steps. We need to have multiple robots that looks for keys in different sections. So I'm not sure if it's going to be that hard actually. I wonder if we just can keep the current algorithm as is and just do some small changes in order to get the right result here. But I'm gonna look at it, do some work and see if I can get this to function. And we are back, and we got the result 1628. So let's see if that is the correct answer. It is! You get a gold star, I get a gold star, everybody gets a gold star. So, what changes did we need to do? We had to, after we've read everything in, we went through the drawing and we put a robot ID on each of the robots. As the example we changed here, here was the first robot, but now we put the 4 robots into their own quarters. So they will go through and look for keys at their own leisures. So we need to give them an idea. The funny part is that I actually had some code already in KeyPath that said that the value should be below 5. So everything just worked very well for me because I had 4 empty spots for the robots. I didn't know about the second challenge, I swear. So that was a very fun thing. So what we do here is that we remove the part up here that actually removed the robot from the picture, and we kept them into the initial drawing. Then when we have figured out that we need to move a robot to a new location, here we will remove the robots that we need to move from that location, and then we will draw a new robot at the new location. And we have changed close to marker, so it actually will return the value of the robot that is moving, and we will use the value 1, 2, 3 or 4 to actually show the path that we fill in for each robot. But other than that, pretty much not so much have been changed. So if we look in check if draw, it will return the value of close to marker, which is a short, and otherwise we return 0, and that is when we don't, when the robot has not moved. And the same goes here, that we will look for that the drawing position is above 0 and below 5, so it's 1, 2, 3 or 4. And if that will we will return that value here. So that's pretty much it. So that's it wasn't that large of a change, but that was pretty much out of dumb luck that I didn't have to change that much. We just give them an idea, and then always as I filled in the path, I filled in with 1s, 2s, 3s or 4s, depending on which robot was doing the actual pathing. So I think I learned something today. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you like these kinds of tutorials or puzzle solving or interesting new Java libraries, please subscribe. If you have any comments, leave them down in the comment section down below. And I really hope to see you in the next video.